Well, hello everybody, and welcome to today's webcast, Underground Stormwater Infrastructure, Solutions, Deficiencies, and Maintenance Protocols, brought to you by Stormwater Magazine and sponsored by AQUALIS. My name is Angela Godwin. I'll be your moderator today. We do have a few brief housekeeping items before we begin. The audio and slides for today's presentation will be pushed out to your screen automatically. You don't have to do a thing. And a PDF of those slides is available in the event resources area, along with a few other helpful documents. If you are running any pop-up blocking software, we do recommend you disable it to view this webcast. We also recommend you close down other applications for better performance. If you should have any technical difficulties, please submit your issue through our Ask a Question box, and a member of our webcast support team will work with you to correct the problem. That Ask a Question box is also how you can submit questions for our presenter today. We'll discuss your questions during the Q&A portion at the end of the program. A certificate of attendance is available, and that will be issued automatically via email within 24 hours. You'll also be able to download it at the end of today's session. For your convenience, the presentation you're going to see today will be available on demand within 24 hours of the live event, and a reminder email message will go out to all registrants with a link to that archive. It'll also be accessible for 6 months at stormh2o.com. One final request. Your feedback is very, very important to us, and we do hope that you'll take just a moment at the end of our session today to complete a brief satisfaction survey. And with that, we can move on with our program. So unlike stormwater control measures like ponds, bioswales, or green roofs, underground infrastructure literally doesn't see the light of day. Because they're below ground and out of mind, these systems are often neglected. But to ensure proper functionality and to mitigate flooding and sinkholes and property damage, these systems require specific maintenance. Here to explore further, we are very pleased to welcome Cara Sabatino. As a member of the business development team at AQUALIS, Cara is responsible for all branding and services communications for this leading water resource management organization. AQUALIS has over 20 years of experience in managing water resources that can be applied to construction and post-construction activities, with services ranging from comprehensive stormwater and lift management, CCTV underground pipe inspections, vector and jetting services, and hydro excavation applications. The AQUALIS team is expertly skilled to provide professional and holistic services to all projects across the United States. And now, without further ado, I will turn the program over to Cara.
Well, thank you, Angela, and thank you all for joining us today as we discuss underground stormwater infrastructure, solutions, deficiencies, and maintenance protocols. So within this webinar today, we're going to look below the surface to underground stormwater infrastructure to showcase the deficiencies, aging infrastructure risks, and how proper preventative maintenance can increase the life cycle of these stormwater control measures. So as Angela has briefly introduced me, it's always really nice to know who's behind the screen during these sessions. As Angela said, my name is Cara Sabatino. I'm the marketing director here at AQUALIS. I've been in the marketing and communications field for over 10 years and joined the AQUALIS team more than a year ago. And so at the closing of our session, I'll tell you more about AQUALIS, but for a brief introduction, we are an environmental organization with a focus in water management and support services for stormwater and lift station assets. And we provide comprehensive services from preventative stormwater management to complete stormwater repairs, as well as we provide ancillary services like underground pipe inspections, vector, jetting, and engineering consultations. And we are proud to service all of the United States plus Puerto Rico. So during our webinar, I'm going to walk through the following learning objectives. We're going to break down the functionality, components, and variations of underground SCMs, including catch basins, detention vaults, and dry wells. Additionally, we're going to look into the risks associated with neglected systems that can lead to deficiencies like sinkholes and corrosion, sediment buildup, and flooding. We're also going to explore restorative repairs through real-life case studies, including showcasing things like storage tank replacements, structural implications, and proprietary device negligence. As with all stormwater assets, Preventative maintenance is essential to extending and preserving the life cycle of these underground stormwater infrastructures. So we will also discuss corrective maintenance, which trends to be a common practice for these neglected systems. And it would be impossible for us to talk about underground infrastructure without addressing proprietary devices. And as I mentioned, we're going to walk through a case study that includes a neglected stormwater vault with the use of proprietary filter cartridges. So we've established our learning objectives, so let's go ahead, let's get started. So in this next section, we're going to address industry standard underground SCMs and proprietary devices. So when we're looking at underground systems, we're going to discuss stormwater control measures that treat water quality and water quantity. And since there are so many variations of underground stormwater systems, this webinar could in actuality take the entire day. But we're going to briefly introduce a few of these systems and then dive a little deeper into the maintenance and repair protocols. So there's more below the surface, and much like icebergs, and we're going to refer a lot back to this iceberg today, is underground stormwater infrastructure provides more than what meets the eye. So in many cases, these systems are utilized in parking lots and roadway infrastructure, commercial, residential, and industrial properties, and moving water from impervious surfaces and directing that runoff to these systems to manage peak volume and quantity storage and slow water release. So essentially used in areas where property utilization isn't available above ground. So we commonly see in the Northeast and highly densely populated areas. And these solutions are very successful in treating not only quantity, but also the quality of stormwater runoff. And while the footprint above ground is minimal, the real estate below ground can be quite expansive. And this is to ensure the proper movement of water to reduce that runoff flow. And while successful in treating water quantity and when coupled with those proprietary devices, treating water quality, these systems are just prone to failure just due to the nature of their placement. So identifying these deficiencies and quality issues to above ground systems can be easy to spot. These systems underground and their expansive nature are prone to deficiencies that aren't detected until it's, a massive failure within the system. So without a professional, these systems can be at risk for costly repairs. So identifying these deficiencies before they develop into structural integrity issues, this ensures the life of the system and reduces environmental impacts and concerns. So engineered underground SCMs, so they offer flood control, reduced erosion, and groundwater recharge, and by slowly moving the stormwater runoff to areas with densely impervious surfaces, this solution can move the water to slowly reintroduce to the watershed. So these include large pipe systems which slow down and hold that stormwater runoff, commonly paired with proprietary devices so that water quality can also be treated. And we typically hear that underground stormwater infrastructure is only a solution for water volume, but solutions to hydrocarbon, phosphorus, and other heavy metals can all be treated with these proprietary devices, especially depending on the region and the pollutants that are being needed to be targeted. So underground SCMs, they filter, settle out, and separate stormwater pollutants that may be present. And so sediment and catch basins settle to the bottom, and then these filters remove those pollutants and slowly reintroduce that filtered water. So installed beneath parking lots, streets, and open spaces, these provide additional public safety as well and security in comparison to things like the above ground stormwater ponds. As mentioned in the previous slide, underground systems really do maximize that space below ground to minimize impacts to the land above. So to also optimize property usage, so aesthetically appealing since these systems are found below ground, they don't impact landscapes or design of properties. And benefit developments with limited and or high value land costs. So from the picture, you can see how the footprint is horizontal placement within 4 feet that is undetectable or minimal disruption to the above ground land use, in comparison to that 8 feet diameter corrugated pipes where you see the actual scaled photo to the height of these pipes that are installed underground. So proprietary systems and devices. So these are manufactured, they're either prefabricated or customizable stormwater management assets, and the treatment devices can be categorized as either filtration or separation. So within that separation category, this can also be further broken down into chambered and hydrodynamic. And later we'll talk through a hydrodynamic separation device as well as a filtration proprietary device. So permanent stormwater treatment products, so they treat stormwater before discharging to another BMP, like large corrugated pipes, or to a body of water, and underground or surface level with underground components. Now, these off-the-shelf stormwater filtration products that minimize engineering costs. So these are systems that are tried and true methods for water quality treatment. So they are a popular solution that ensures water quality is established to protect the local watershed. And within this process, working with engineers and regulators on the quantity of devices, which is to capture that optimized result for pollutant removal, is essential. Also preserves that high value land space like we just talked about in the previous slide. These retrofits also to existing stormwater systems. So these easily can be installed to already existing infrastructure at a low cost, but with a high impact on water quality treatment. And one or more catch basins and drop inlets funnel stormwater to proprietary devices for treatment before discharging into a secondary treatment area, such as detention basins. So these are what we call SCM series or treatment trains, all working in complete harmony to move stormwater and runoff and remove pollutants. Go back. So underground and proprietary systems utilize a combination of both natural and engineering processes to manage or treat stormwater before it's released into the environment. So back to that treatment train, as we just discussed, these systems aren't a one solution, but typically used in combination to ensure proper management of runoff, to avoid flooding, and treatment to ensure that environmental quality standards and to further protect the watershed. So filter materials can include sand and natural filter mediums, manufactured filter mediums, those hydrodynamic forces, porous soils. But really important to note that the medium chosen is the best solution to treat the specific pollutant. So this all depends on the region and the targeted pollutant that you're trying to remove. And volume control measures include storage tanks and vaults, float valves and sensors, and groundwater recharge, and engineered outlet control devices. And so most underground systems, including those listed, do offer both quality and quantity management, but one have one or the other as their primary focus and goal. So catch basins, we've mentioned them a lot. They're a very common solution and stormwater asset. They're designed to collect stormwater runoff from non-permeable surfaces. These come in a few different designs. So this includes the drop inlets, which is the photo on the bottom left, and the curve inlet, which is the middle photo, and a catch basin, which is that photo on the bottom right. So these systems take that flow of water underground through pipes, eventually to the pond or the watershed. And these are usually found in parking lots and roadways. And we do expect that there's going to be normal wear and tear. These systems are typically that first line of stormwater defense in parking lots. And with that, we see a lot of failures. So the failures that we see that decrease the life cycle of a catch basin, this includes trash and debris, which blocks the function or the proper drainage, concrete and brick deterioration or mortar deficiencies. So stormwater can pass through the identified deficiency, saturating that outside soil, and then that soil can then backwash into the catch basin, which ultimately causes that void, and then that eventually causes a sinkhole. And if not properly maintained, these can fail, which causes flooding in parking lots, impacting businesses, potential liability due to injuries from sinkholes where they form. Proper root cause identification of the deficiency really ensures a long-term repair and prevents that same issue from reoccurring or that same sinkhole from reoccurring. So we're going to go ahead and we're going to break down these components to a catch basin. So the junction box. So often these are installed as large concrete boxes that come either ready-made or precast. So this is where that water flows and access for that water is held. And human access as well for maintenance and inspection purposes. So the junction box cover, so this is sized to that opening. The adjustment riser, so this is calculated that the junction box is placed in the ground, and that adjustment riser is selected to fill that gap between the junction box and the surface. So this often erodes more quickly than the rest of the catch basin structure, so it must be monitored for degradation. So these are either made from plastic or precast, block, or brick and mortar. The metal frame of the catch basin, so that's there used for supports, and then the metal grate, of course, for the catch basin, which is the common look for the catch basin. So we're now going to talk a little bit about detention vaults. So detention tanks or underground storage tanks, these are all utilized to store peak volume runoff flows and release the water at a slower rate. So underground storage tanks can be made from concrete, steel, aluminum, plastic materials. And we're going to walk through a case study a little later on in the presentation regarding detention tanks and their common deficiencies, again, stemming from that lack of maintenance and inspections. So these systems are not designed to enhance water quality, and they're typically used with those proprietary devices to meet stormwater discharge quality requirements. And these type of systems can have issues with weight restrictions like overcompaction, above ground weight from inventory staging, or large vehicle overpassing. And corrugated metal pipes, these are prone to rust and corrosion, and without proper maintenance, where water pools and collects over periods of time, just due to sedimentation blockages, including joint issues as well. So the proprietary filters, these are located within stormwater vaults or detention tanks. So these filters house rechargeable media cartridges to target different pollutants like TSS, hydrocarbons, nutrients, and heavy metals. As I mentioned earlier, the media chosen really depends on the specific pollutant that's being targeted. This includes natural or engineered medias. So these cartridges trap particles and absorb the pollutants. And float valves are housed in the center opening once the cartridges are full of filter water, releasing the water at a slowed, specified rate. So preventative maintenance is essential here, preserving the lifespan of these systems, that the proper water quality is upheld and the treatment is targeted appropriately. So maintenance includes cleaning the vault and the tops of these filters, and depends on how well the areas above ground are really maintained to extend the life cycle of these systems. You know, is street sweeping occurring often to prevent heavy sediment and accumulation? Is the vault being inspected for increase in trash accumulation? And these are all things to consider to ensure the life cycle of these proprietary devices. In general, you know, we expect 1 to 5 years of a life expectancy, but they can be extended when that proper preventive maintenance, which includes either vector and jetting of the vault on a routine basis, really can help extend that life cycle. So I'm going to show this animation where this is showing as the water and the pollutants come into the filter, the pollutants remain, and the clean filter water is washed out. So chamber units, or those hydrodynamic separators. So these provide effective solutions against pollutants in stormwater. So they work by water bypasses that lower chamber to prevent disruption of previously removed sediment and petroleum that is accumulated within the lower chamber. So the free oil then rises and is trapped within the insert. So the treated water then bypasses the wear, doing infrequent high flow periods while diverting sediments and floatables. So routine inspections, this is to ensure oil and sediment accumulation rates, and frequent vac truck cleaning to remove those collected oils. So we'll go ahead and we'll show how the system works with animation. So this is during normal operating conditions. The water flows in, and the larger oils and sediment is separated, the oil is trapped, and then the water then swirls out to be removed to the outlet, to the rest of the treatment train. Now we're going to show during those peak flow conditions. During peak flow, the water bypasses the lower chamber to prevent disruption of previously removed sediment and petroleum that has accumulated within the chamber. So next we're going to address those implications of underground stormwater system neglect that we've talked briefly about. So referencing back to our iceberg, right? When problems reach the surface, it has likely been an issue for a while. So the out of sight, out of mind mentality is very prevalent with underground infrastructure, especially for those that may not be aware of the assets that they are either required to maintain or that they own underground on their property. So these assets are especially prone to failure, as areas of concern are challenging to identify by everyday visual signs. So more often when in disrepair, it is extremely costly to correct. So problems may only be noticed once they come to the surface, literally, like sinkholes, pooling of water, as we see in this photo right here. An overall lack of awareness is a common factor we tend to see with these systems, like poorly maintained stormwater assets due to turnover in positions. So we see this frequently in locations where the next manager isn't aware of the responsibilities that they hold. Deficient knowledge of regulations, so there's unawareness of proper regulations or O&M agreements on their systems. There's costly repairs required to get the system back to design function. So simply put, it's expensive. It's expensive to repair, and some just don't have the budget unless motivated by a compliance issue. So the property owner might not move forward with repairs until absolutely necessary. NOV potential for non-compliant systems, lacking proper budget allocation for maintenance. So instead of focusing on the emergency response, rehab, and repairs, and record keeping. So neglected systems can face dangerous, widespread, costly failures, so sinkholes and flooding, just to name a few, especially when you want your system to function as designed during historic rain events. Failures can quickly be exacerbated by the condition of the underground systems. So common signs of deficiencies. So we've talked briefly, but we're going to break them down a little further here. So buildup. It's especially visible in and around inlets and catch basins. So due to their design, this is where trash and debris is meant to build up. But if routine removal of the trash is not upkept, the catch basin can be completely blocked, which ends up causing flooding. Hydrocarbons are commonly found in the catch basin, so those proprietary devices, as we spoke about, can assist with capturing these oils and sediments, debris and trash, all clog producing items that's easily treatable with routine preventative maintenance. So cracking and settling. So while cracking and settling does not always warrant further action, it's important to monitor catch basins to ensure system function, safety, and compliance continue to be met. Damaged piping, so detectable with underground pipe camera inspections and preventative maintenance inspections by verifying that proper water flow and sediment buildup. And many times, property owners are only alerted to this issue when there's pooling of water or sinkholes forming above ground. Consistent bypass, so typically leading to bigger issues like the sinkholes, water pooling, as the runoff is not reaching the water treatment cells. Visible sinkholes. So we're going to talk more about sinkholes in the next slide, but this is the deficiency that requires attention right away. Water pooling. So is usually indicated with flooding in parking lots or water collecting where not originally designed or intended. And as we walk through each of our case studies, we're going to revert back to these deficiencies as the recognized defect or system failure. So sinkholes require immediate attention, and as we addressed with the iceberg, when these reach the surface, it typically indicates a larger issue below. So collapsed subsurface hollows that appear as depressions in the ground surface in which the rainfall can drain is a really good definition of sinkholes. So that water displaces the soil and then creates this concave cavity. So structural defects involving piping or other below-ground stormwater infrastructure has become defective are commonly the causes of sinkholes. This includes legacy piping and aging infrastructure, which are at risk of failure or at the end of their life cycle. And underground infrastructure is at risk of creating sinkholes when pipes crack, fracture, or have structural failures. So root cause analysis really needs to be implemented through underground video pipe inspections, either smoke tests, percolation tests, water dye tests, or geophysical studies or surveys. So when water escapes pipes and flows over surround rock structures, eroding cavities that eventually collapse, and these also form sinkholes. So as we talked about that cavity that can be formed around a catch basin, that same process can occur around any piping with any faulty joints, cracks, fractures, or an increase in compaction or weight. So minor sinkholes can quickly develop into structural and safety issues if left unaddressed. So it's really incredibly time sensitive to address these sinkholes. So we talked a lot about preventative maintenance, but we want to make a point to discuss corrective maintenance. So this is a degree above preventative maintenance when we need to take a site back to compliance. This is due to a length of time where the system has been neglected. Repairs and major restorations can be added into this category as well, but we're going to address repairs as its own category in the next slide. So common corrective maintenance services include factor services, jetting services, trash collection and removal, underground pipe inspection or CCTV inspections, and we're going to break each one of those down in the next slide as well. So additional to the corrective maintenance, the following are solutions that diagnose, treat, and inspect underground systems. So underground pipe services, so this technology can identify suspected pipe damages, operational obstructions like the accumulation of debris, sediment, root intrusions, also compromised systems with complete pipe collapse or serious defects can also be detected. And so for preventative purposes, pipeline condition can also be verified. So this is to detect minor defects due to installation, assess overall pipe health, and ensure the life of the underground pipe. Vector services. So utilizing high suction power, these trucks collect and remove large volume of debris of both wet and dry solids. So this can be used and applied with a combo of jetting to clean catch basins or vaults to remove accumulated sediment. So jetting services. So these use high pressure water to dislodge sediment, clear compressed buildup. So this solution is environmentally friendly and highly effective to clean and maintain underground systems. And preventative maintenance and inspection services. So these are management programs to provide routine maintenance on a monthly or quarterly, even a biannual schedule. So this includes visual inspections and sediment measurement evaluation of including debris removal and reporting any deficiencies over time. And really having a professional familiar with the system includes consistent photos over time to watch any deficiencies if they are small and monitor them should a repair be needed eventually. And repairs. So underground repairs are essential, and even with routine maintenance can be inevitable. So this can be due to aging infrastructure, even human error such as damage from cars, vendors with lack of knowledge of those systems, which is actually one of the case studies we're going to talk about here soon. And when corrective maintenance is not sufficient, when restorative or rehabilitation can then be applied. So repairs include pipe replacements, pipe lining repairs, structural repairs, and sinkhole repairs. And then we can break those repairs down into rehabilitative and restorative. So restorative repair consists of a variety of isolated or small-scale maintenance work needed to address operational problems. So simple grate or drain replacements and even vector work can fall into this area. Rehabilitative consists of large-scale maintenance and major improvements needed to address failures within the stormwater management facilities. So work may be required by an engineering design with construction plans to be prepared for review and approval. And this work may also require specialized maintenance equipment or surveying, construction permits, or assistance through private contractors and even consultants. So in general, if large equipment is required to work underground, this repair is probably a rehabilitative repair. And as with any deficiency within underground systems, these need to be addressed swiftly to preserve the entire SCM treatment train is performing as designed. So now it's time to dive into some real-life examples that include restorative repair, rehabilitation, and corrective maintenance. So this is a great example of ensuring preventative maintenance has been provided, but human error interfered and resulted in a major rehabilitation project. So this site repair is in Florida, and it's still in progress, but the stormwater vault ceiling essentially was damaged by a parking lot vendor. So they went to repair and replace a portion of the asphalt. And unfortunately, the vendor didn't refer to the site plan or the multiple weight limit signage that was on site that would have indicated that there was something going on underground at this retail location. The vendor ultimately drilled holes into the vault, altering the structural integrity, thinking it was control joints. So the site had to be blocked off as engineering and city officials are coordinating to ensure the repair is appropriately addressed. So issues currently that we're facing at this location include that it's rainy season in Florida, and we need that vault to be dry to begin work, as well as getting our hands on precast construction materials. And we really thought this was a timely case that came up as we were organizing this PowerPoint. And we found essential to showcase how the missing education for these systems can really cause major deficiencies in underground systems. You know, depending on when you do everything right, sometimes it doesn't matter, like in this case. So not only out of sight and out of mind for property owners, but all vendors working in and around these systems as well. So this next case study is one from Arizona and one that we currently have in progress as well. And due to the nature of the geography and topography in Arizona, the above ground real estate isn't adaptable to stormwater infrastructure and ponds, just really aren't as prevalent in that region. So since rain is infrequent, these systems are 20 to 25 years old, made of corrugated pipes and deep dry wells, which are developed to send that water right back to the water table by reaching that permeable soil where it can actually infiltrate back into the soil. And in fact, Arizona is one of the states with the largest dry well programs, so they have over 52,000 throughout the state. But the site experienced a lack of maintenance for quite some time, that the sediment was not flowing out appropriately, and that water began to pool and remaining in the pipes, so this caused corrosion and the pipes to eventually rust out. So the water was bypassing and infiltrating the surrounding material to ultimately cause that sinkhole, and the weight gave way to that complete collapse, as you can see in that photo here. So deficiencies identified here include that buildup, visible sinkholes, damaged piping. The top of the photo here showcases that oxidation of the water pooling, and the bottom photo displays that sinkhole that's on site. So the solution to this one includes a major rehabilitation of the system. So it also comes at a high expense. So the storage tank system includes 130 linear feet of 8-foot diameter corrugated metal pipe, which is all being replaced. So the system received new bulkheads and risers and storm grates as well. Proper compaction below the system and above the system is being calculated to ensure the life and integrity of the system. Additionally, the same issue is occurring in the neighboring property, in which actually a car fell into the sinkhole this past week. So this case will be completed in the next month or so, and then following we'll provide routine maintenance to continue to monitor this brand new system. So this was a site we were contracted to perform a routine inspection. So During the inspection, the stormwater team found a contact filter valve and quickly assessed it to be out of compliance with manufacturer guidelines. So it was likely functioning in a bypass mode or not operating such that water quality and quantity rates were being achieved. So our inspectors observed significant sediment and debris up and around and on top of the filters that were located inside this underground system. So the manufacturer recommends that these cartridge replacements should occur at the 1 to 5 year cycles, really depending on the results of the routine inspections. So we were able to rehabilitate the storm filter vault back to a functional and effective state. So this includes a vacuum and pressure washing service performed on multiple systems. So includes the stormwater filter vault pretreatment, storm gate structure, inlet, outlet bay, and cartridge bays. So all of the 18-inch filter cartridges were replaced, which was a total of 112 of them. And the under drain manifolds were inspected and jetted with water reclaimed as needed. So all reclaimed material was then disposed of at an approved off-site facility. So this is a recent completion we did in Raleigh, North Carolina. So these are the before photos that you're looking at right now. These two sinkholes formed in a drive lane above large diameter conduits at an apartment complex. And these pipes are designed to guide stormwater runoff, and they ended up facing years of wear and showed signs of extreme corrosion that inevitably led to displaced retaining wall. So no longer adequately set, stormwater was misguided around the outside of the conduits rather than through them. So these compromised pipes led to the destabilization of surrounding surfaces, and stormwater erosion created pockets of subsurface caverns, also known as sinkholes. So eventually the road above these hollows became so weak and they imploded. So then those sinkholes were ultimately revealed, as you can see in those top two photos. So AQUALIS engineers performed cast concrete pipe lining repair on the pipes as the pipes were still in a really healthy condition. So using this technique, professionals created a 1.5-inch concrete pipe within the existing conduit. So this process sealed the pipe from further damage and increased the stability of the conduits to prevent additional stormwater from being diverted around the pipes. And once the conduits were stabilized, grout was injected around the pipe head walls and within the sinkhole to fill the voids and compact the soil, securing the pipe repair. And once this sinkhole was filled, damaged asphalt was replaced, and the entire drive lane was then safe to travel on once again. So you can see these are the completed photos with the completed repair, with the sinkholes filled and repaired, as well as the concrete head wall repairs. So the water is now able to flow as designed. So as we highlighted the owner responsibility throughout this presentation, this next section, we're going to explore a more in-depth into the expectations and responsibilities of property owners. So system and operation and compliance include routine maintenance. If property has O&M agreements, these guidelines provide the accurate and outlined maintenance schedule for the systems. Inspection, at a minimum, local regulations require inspection of the system to ensure the SCMs are performing as designed and protecting the local watershed from increased pollutants. Repairs, so this is addressing the restorative and rehabilitation type repairs that are expected through the life cycle of these systems. Record keeping, so going back to routine maintenance, ensuring that O&M agreements are met, documented, as well as inspections remain essential. So notices of violation, communicating with the stormwater professional that can communicate on the property owner's behalf to local regulators to ensure proper documentation and protocol is followed. So correcting these violations with deadlines. So again, back to that communication part. If a large rehabilitation is needed, the time frame for completion may not meet that violation deadline. So this is all essential to communicate and work with a trusted provider. And then providing all proper reports. So all communication is based and essential to not ignore any type of fine or violation. So as we circle back to preventative maintenance, ensuring these four are met will help extend the life cycle of underground infrastructure. So starting with inspections, so these help to evaluate the condition of most underground systems by the monitoring the level of water, oil, sediment, trash. Ports and access points are used to collect material for samples for measurement. And confined entry is not always required to inspect these systems, but sometimes it is. And proof of maintenance must be available upon request as well during these inspections. Ports and access points are used to collect sediment amounts as well. So trash removal and accumulation is an important part of the routine preventative maintenance. So floating debris is removed during this process, and this helps to reduce the chance of clogging and possible restoration or rehab costs. Sediment evaluation, so using an industry tool to measure that sediment and depth. So this helps to indicate a level that is acceptable versus a level that is actually out of compliance. So routine measurements can also alert to small changes in the system to investigate with underground inspections as well. And then out of scope. So these are items not part of routine preventative maintenance, however, can be included in service agreements, especially depending on the type of system. As in some regions, catch basin cleanings via vac and jetting is actually required annually. So actions you can take to ensure proper maintenance and functions. This is a great checklist to take with you. Education, so essential to spreading the word on the importance of stormwater assets, treating runoff, and protecting local watersheds. Implementing routine inspections and maintenance with certified stormwater providers. Install retrofit and repair systems to optimize function. And then keep properties free of trash, debris, and landscaping clippings. So all back to that education portion, which is so important in making sure that your system is staying healthy and functioning properly. So as we close, I want to briefly just cover kind of the future of stormwater in regards to technology. As we discussed aging underground infrastructure, we have to look to technology to help provide insight to these systems underground. So how do we use data to drive our next steps in stormwater? So with information within reach always, as we are used to, it's time to adjust how we approach aging underground stormwater infrastructure. And how can we capture a full picture of stormwater is managed in systems with the use of technology? So we can use data from sensor technology to understand how best to rehab or retrofit to meet new capacity needs, and we can enhance further stormwater design to meet new capacity requirements. And overall, data allows us to make better budget decisions, prioritize repair projects amongst multiple SCM assets, and identify failures or flooding potential, all before extreme weather events occur. So, as most industries, technology is an important resource for capturing data and improving systems, and it's available in stormwater. So AQUATRAX is a cloud-based network sensor that monitors the health and status of SCMs in real time. So all within a dashboard accessible from a desktop or mobile device. And these systems allow for monitoring across multiple geographies. This compares data to make preventive decisions before extreme weather impacts the region. The system includes weather forecasts and alerts to prevent any major catastrophe to the system before it occurs. So insights provided by the sensor system give municipal and property owners the information to make appropriate rehab or retrofit decisions and planning for the future. So this is a view of the dashboard, and it's provided to users with key data points that can assist in monitoring systems. So the system monitors water temperature, so this can assist in monitoring systems prone to impacts from thermal pollution. Total outflow, this gives an overall health assessment on the system and if it's functioning as designed. Total precipitation, so accurate precipitation and how that impacts the system through outflow, and total capacity, monitor capacity and receive alerts when at critical levels that would end up requiring intervention. So the system gives you a holistic view to make decisions on how to prioritize repairs, alert maintenance for crews, on potential needs for monitoring, and overall provide data that can assist in making decisions for properties or projects. So the technology surrounding these sensors will continue to improve and advance to further meet the needs of municipalities and property owners and further protect the life cycle of these underground systems. So as we wrap up, I'm going to share just a brief couple slides about AQUALIS and who we are, and then we'll get to the Q&A portion. So AQUALIS is the leading nationwide provider of stormwater and lift station management services. So these services include preventative maintenance, corrective maintenance or repairs, retrofit and redesign, as well as emergency response. So AQUALIS helps protect your assets, mitigating notices of violations or on stormwater control measures, diminishing flooding risks, and supporting efforts in environmental stewardship. So we partner with retail, commercial, industrial, municipal, healthcare, hospitality, you name it, of industries. We service single-site and multi-state organizations through our preventive maintenance programs. We are an organization with over 20 years of experience in water resource management. So we provide innovative, leading-edge solutions to meet budget constraints and exceed compliant expectations. So programs that ensure quality, like our quality assurance program, we strive to deliver an exceptional quality and raving fan experience. So as the leader in stormwater and lift station management, we are pleased to partner with and educate property owners on the importance of preventative maintenance and water compliance. With the AQUALIS preventative maintenance programs, we can help building owners and facility managers avoid costly violations, reduce liability, and improve system performance and increase overall property safety. So we are a team that prides ourselves in safety, compliance, and education. Our teams are highly specialized in their fields, from stormwater inspectors to certified small space training. Our certifications include state-level certificates where applicable, as well as product-specific certifications to properly install and manage these stormwater assets, like those proprietary devices we talked about today. And many of these certifications include routine continuing education, so for renewal to ensure that we are following the most up-to-date regulations and processes. So if you're interested in learning more about AQUALIS and partnering with a stormwater management or lift station provider, you can reach out to us directly on our website, which is aqualisco.com. Again, I appreciate your time today as we end our formal presentation. And as we get into the Q&A portion of our session, I'm going to have Michael Brewer, who is our Vice President of Provider Services for AQUALIS, assisting fielding those questions today. So Angela, if you want to take it away, we can get started with that Q&A portion.
Absolutely, Kara. Thank you so much. What a fantastic presentation, and welcome, Michael. So we had a lot of great questions coming in during the presentation, and we're going to try to get to as many as we can between now and the top of the hour that we have with you all. I do want to let you know that any questions we don't get to, we will share those, of course, with Kara and Michael, and perhaps they'll be able to answer those offline. But for now, let's go ahead and dive in. Kara, here is a question for you. What are some site-specific factors that would make certain underground systems or proprietary devices more fitting for a property? And I would direct that to Kara or to Michael, either.
Yeah, I'll take that. So, good afternoon, everyone. So, there are certainly lots of site-specific factors. So, one thing that we need to consider are the types of soils that are present in the area where your property is located. How much impervious surface is going to be on site, and then we need to look at what are some of the regulations of the existing city or municipality or county and what the requirements are for those rules. And based on that information, you can put together a plan for what types of BMPs need to be in place to manage the stormwater effectively.
Okay, terrific. Thanks, Michael. Next question for you. How do you know what is normal catch basin settling and what is a possible sinkhole?
So this is a good question. So it is oftentimes difficult to see, but there are a couple different signs that tell us what is the root cause of the sinking. The first is if you look inside of the structure, and if you are able to see mortar deficiencies or a lack or non-presence of mortar in between joints, like for instance where the section of pipe enters into the junction box. If there's not mortar there, what happens is that moisture and water move through there, and along with that water, it takes sediments and fines and the soil with it. And so if you have sinking around a structure, you'll want to look inside of the structure to see if you can find evidence like water moving through those joints. And if you see that, then that's most likely the telltale, and it needs to be corrected as quickly as possible.
Great. Excellent advice. So now we had a question come in specifically about the Chandler, Arizona case study that Kara discussed. And the question is, did the system have a required maintenance and/or inspection schedule, either required by an NPDES or similar permit or by designer? And what was the recommended inspection frequency, and had it been followed?
So specifically for that site, I know that I can't speak to whether or not maintenance was performed, but I do know that in many instances, underground systems like this need to be maintained quarterly at a minimum, in which we can get our eyes on the system. We can take sediment depth measurements. When systems fail to this point, it is very likely that maintenance systems were not implemented because it gets beyond a point of repair. So if we're in there on a quarterly basis maintaining or inspecting your underground system, we're going to identify these types of deficiencies much sooner in the process. And there are repair measures we can take that can fix this before it gets beyond that certain point, and where we would not have to actually cut it out and remove it entirely and replace it. We could do pipe patches, or we can do cure-in-place pipe depending on the size of the underground detention system itself. So lots of different ways in which we can fix it when issues arise, but it's critically important for us to have a maintenance plan so that we can get our eyes on it.
Excellent, great, thank you so much. Let's talk a little bit about sediment depth. We had a question come in asking what industry tools are used to measure sediment depth in various underground facilities?
Mm-hmm. So the most common is a product called the sludge judge. It's a clear plastic tube that you can push down into the bottom of the, in many cases, the isolator row of an underground detention system, or an inspection port. Oftentimes are built into these systems, and it's designed specifically for that reason, so that you can push something down into those areas, and you create pressure once you felt the actual bottom of the hard bottom of the structure, create some pressure, and then you can pull it up, and it will actually visually show you what sediment depths are in place. Now, those tools are very, very good, and they're very helpful. The problem we run into, because of the amount of maintenance visits we do, these clear plastic tools oftentimes get damaged or broken. The majority of our trucks have a PVC pipe on top of the truck where we place these, but occasionally, they get dropped or broken, and so it's very difficult to keep them operational. And so what we have done in many instances is taken different types of measuring sticks and notched out the inch marks And what happens is when you push it down into the sediment depths and pull it up, the inch marks capture that little bit of sediment. And so it gives you the visibility to see what sediment depths are in place.
That's really neat. That's very resourceful way to tackle that. That's great. Michael, we had a couple of questions come in around bacteria. So I'm just going to kind of summarize into one question for you. And just curious, viewers are wanting to know whether there are devices or filters available that can remove bacteria from stormwater runoff, and how well these types of systems are at doing so.
Yep. So there have been some studies around trying to remove bacteria, specifically bacteria from stormwater. And you know, it's been one of these things. Stormwater BMPs have not had a tremendous success consistently removing bacteria. Some systems do better than others. For instance, any type of sand filter, any type of media filter that water has to pass through does a much better job of collecting bacteria or trapping bacteria. And so if that is a requirement there, then I would try to design something such that there is a media that the water has to pass through. Without that, stormwater BMPs historically are not great at removing bacteria. They're really mainly designed to remove phosphorus or metals or hydrocarbons, and most importantly, sediment.
Okay, great. Thank you. You know, we also had a couple of questions come in around mosquitoes, so I want to make sure we bring that up since so many of our viewers were curious about that. How do you address devices or systems that breed mosquitoes? How would you correct this in existing systems, or design a system so that mosquitoes are not a problem?
Yep, great question. And so as we're all aware from our properties, I mean, I myself live in the Southeast, and so anytime we have a rain event, I always try to go around my property and you know, turn over empty trash cans or buckets. Mosquitoes can lay eggs in even the smallest amounts of water, and so any standing water that is not moving needs to be addressed. In particular, in stormwater ponds, when you have cattails, other types of vegetation, mosquitoes do a very good job of breeding in those areas as well. So we need to remove cattails. Anytime we cut vegetation in stormwater ponds, we try to remove that dead material from the water itself. When we leave that in place, it just creates a perfect breeding ground for mosquitoes. So my suggestion is to keep water moving, try to prevent standing water, stagnant water, and then that water, let's try to remove any type of debris that covers the top of the water, which really promotes mosquito breeding.
Okay, great. Thank you. We also had a couple of questions coming in around inspections. So again, I'm just going to kind of summarize, but our viewers were curious about, you know, who typically handles inspections? Is that Public Works? You know, who in the municipality? And what are some strategies, you know, for making sure that inspection and maintenance gets done and documented?
So we obviously perform lots of inspections and maintenance visits, and they are in many cases one and the same. When we arrive on site to perform a maintenance visit, it is the inspection itself that determines what maintenance activities need to be performed. So if we arrive on site and the vegetation around the perimeter of the pond is 12 inches high, through that inspection, it's determined that we need to cut that grass down. And so we can perform the inspection. Now, that said, the municipality in many instances performs their own annual inspection. And so knowing those dates is very important, because we can schedule our maintenance visits such that the site is in as good of shape as possible prior to those inspections, so that we can prepare for that inspection and make sure that the site is operating correctly. And if there are deficiencies there and present, we can propose that to the client so that we can get those addressed prior to the municipality showing up to perform the inspection.
Okay, awesome. All right, thank you, Michael. You know, we are at the top of the hour. In fact, my clock is showing 1 minute past, and I apologize for keeping you all a little bit over our time, but I do want to be respectful of the time you've chosen to spend with us today. So I am going to go ahead and wrap things up. I do want to let our viewers know, though, that, you know, there were quite a few unanswered questions we couldn't get to. Those will be shared with Kara and Michael, and I expect that they will be able to address those with you offline. So with that, on behalf of Stormwater Magazine and Endeavor Business Media, I want to thank our speakers today, Kara Sabatino and Michael Brewer, of course, for lending his expertise during our Q&A portion. And of course, we want to thank our sponsor, AQUALIS. I'd remind all of you that the presentation you saw today will be archived within 24 hours. You can access that at StormH2O for the next 6 months, and a reminder email message will go out to all registrants with a direct link to that archive. I will ask you to please take a moment to share your feedback with us. I promise you I will read every single one of your comments. There will be a brief satisfaction survey at the very end of our session today. And you'll also have an opportunity to download a certificate of attendance for today's webcast, but not to worry, because one will also be sent out to each of our registrants within 24 hours of today's event. And with that, just a final thank you to all of you for joining us today for Underground Stormwater Infrastructure, Solutions, Deficiencies, and Maintenance Protocols. We look forward to serving you with future webcasts. This concludes today's presentation.